Do this, beast. All right. Guess what we're learning about today? That's right, matrices. I need a mouse. So, I'll give you guys some general knowledge first. A square matrix, if you have a square matrix with nothing but ones in it diagonally, it is called the identity matrix. Because what's the multiplicative identity? What number do I multiply by it and it stays the same? 1. What's our additive identity? Like the one that keeps saying we add 0. So that's the matrix that keeps things the same. Okay. So this is, again, if you're going to do pre-calc, it gets talked about. So I'm just going to do it pretty quick. The matrix identity times the matrix, it just keeps it the same, right? It's the same thing as multiplying by 1. All right. That's going to be important because when we solve a matrix, we need to get one side to the identity. And I'll show you how to do that. But yeah, it's just saying it's true both ways. This is the one. Do you know how we said A times B does not equal B times A for matrices? For the identity matrix, it is true. You can go both ways. AI. Nothing artificial about me. All right. We're going to go. I'm going quick through the reason why this works if you guys are okay with that. So, do you remember when we learned about inverses? If I inverse a function, I get x, right? The identity. If I multiply a matrix by its inverse, I get the identity. So I can cancel out matrices. Why would I do that? That's a good question. All right. Why would we cancel them out? Well, if we have to solve an equation. All right. So, how do we find an inverse matrix? Well, we could reduce row echelon form it. We could use a formula, or we could use our calculators. Okay. In a 2x2 case, this is the formula. If you are someone who needs to find formulas quick, I would start this one. I believe it will come up once where you just need to know that formula. It's not as bad as what you think it is. This is on slide 7. Oh, I'm sorry. Page 4. I'm going to write it over here because I'm going to use it with you guys one time. It's not as bad as what it appears. Because all you're doing is what happens with my A and my D? They flip, and my C and my B get negatives. And that's something called a determinant. If you're ever asked to find the determinant of a matrix, which we aren't doing in here, but next semester, if you're taking pre-calc, you will find the determinant. Okay? Because honestly, the difference between Math 124 and this is just a little bit extra in each section. They're very similar. So let's find the inverse of this piece. This one I'm going to use doing the formula, and then I'm going to show you how to do it with a calculator, and then we're about halfway done. The first thing I would do is label this my A, my B, my C, and my D, right? A, B, C, D. It's the alphabet bit. Huh. All right. What's A times D? So you're doing 5 times 6 minus 7 times 10. Would I expect you to ever memorize this at this current point of your career? Absolutely not. What if you are, now if you go into linear algebra, you're going to use it all the time. Times, switch your A and your D. So that's going to be a 6 and a 5. And then these both become negative. Negative 10, negative 7. Okay? So the math behind it's not difficult, right? It's just there's a lot to do. So that's 1 over negative 40 times these. That's a nice number. When you scalar multiply, it just goes through and hits every number, right? So that'd be negative 6 over 40, negative 10 over negative 40. That's going to be positive. Negative 7 over negative 40. That'll be a positive. And 5 over negative 40. There we go. That's how you find the inverse. Grab out your calculators. Let's see if we know how to do this on a calculator. It'll be okay. You can do this on a calculator. That's what we're gonna do. No, yeah, 100% reduce them all down. I just didn't. But if you're using a calculator, your calculator is going to give you decimals. So first thing I'm going to do is hit second matrix, right? I'm going to edit a matrix. If you you probably still have your matrices in from yesterday, which is fine. You can just override them. It's a 2 by 2. And then I'm going to plug in our original matrix, which I have covered up because not anymore. 5. So go and plug in the matrix, follow along. 7, 6. All right. So I'm going to go second matrix. And now this time, do you remember names will enter onto my screen, right? So I'm just going to put matrix A down. Now the inverse function is right here. It's a button on your calculator, right? Because we used that before, x to the negative 1. So I'm going to go 1, 2, 3, this button down, and hit enter. And boom. Matrix, names, and then you hit enter, and it'll plug in your calculator, and then you use the negative 1, the inverse function. It's the fourth button down on your calculator. Second alpha math, negative 1, x to negative 1. I'm sorry, second Mr. Terwilliger, math, x to negative 1. You do not have to second that one. The negative 1 is right on the actual thing. All right, hold on. Yeah, we're going to roll with this. All right. So there are, for my online folks, there are other videos on Moodle that go through how to do this on the calculator. My in-person folks, here's what I'd like you to do next. Keep your calculator out because we want a lot of practice. Where's my mouse? We want a lot of practice on this. Find the inverse of this matrix using your calculator. Give it a shot. Try it out. If you guys want, what would be beneficial in your notes is to remind yourself to write down what it looks like when you plug it in your calculator. That'll help you out because then you'll kind of have a remembrance of how to do it. Calculators, who knew? Second matrix. This one's going to be a nasty decimal. I would round. Well, if you're writing it down, I would just round to 2 decimal points for this one. I'll show you. Because when we do calculations with this, are we going to write down the matrix or just leave it in our calculator? Well, I'll show you the next step we're going to do. But if you can do this, you can do half of it. No, write the matrix. Write the matrix. What do you mean your calculator stopped working? Are you sure you just didn't stop working? This is what I got. This is what I got when I did it. I'm going to pause this. All right. So hopefully we're getting 0.45 repeating, negative 0.27 repeating. These are all repeating decimals, so I'm going to write it that way. 0.18 repeating and 0.09 repeating, right? Now, let's look at something wonky that happens. Let's do something fun. Let's do something wonky. Ooh, did anyone do that? This one longhand, your determinant was 11. All right, 1 over 11. Anyway, I digress. So example 3, I plugged it in my calculator, and I hit a to the negative 1. If you guys tried along at home, what happened when you plugged that in? It said error. Do you guys remember when we did functions? Does every function have an inverse? Yeah, no, not every function has an inverse. Does every matrix have an inverse? No, some are non-invertible. So this matrix does not have inverse. Here's why. If we do the 1 over AD minus BC, guess what you get on the bottom? 0. So that's why you don't have it, okay? Because you cannot divide by 0. All right, sound good? Because 1 times 8 is 8. 8 minus 8 is 0. Sound good? All right. We got one more thing to do. Oh, it's going to be the same stuff, so keep your calculators at the ready. If you're online, make sure you're using that TI-89 or TI-84 I posted for you guys, or yeah, I would use that one. A matrix is singular if it does not have an inverse, because it does not have a partner, so it's single. That is why. And it is non-singular if it has an inverse. Star those definitions. They might come up. Make sure you understand. So if it asks, is a matrix singular, what would you check for? If there is an inverse. If it's non-singular, you check and see if the inverse works. You could just find the determinant, which is a button in your calculator, but we'll save that again if you go one step further. All right, this is a thing in math. This is a thing that exists. I could have a matrix times x equals a number, and then I would have to solve for that x. Now, quick reminder. How do I get rid of something? I use inverses, right? So if I were, I'm going to skip the next slide. I'm just going to do it here. If I were to multiply both sides by A inverse, what's it going to do to these two matrices? It's going to cancel them. So x would be equal to A inverse times B. So basically what I'm saying is we can solve these equations by finding the inverse of this and then multiplying it on both sides. And you'll get what x and y are. Okay? We got to practice this. It'll be, it's easier to see in practice than theory. Yeah, it is all going to be on calculator. Yep. This is the proof of why it works. This is what I just said, right? Multiply both sides by the inverse. So let's do it. So here's what I would do. You need to make two matrices. You're going to make matrix A, and your calculator is going to be, and I'll go through and do it too. This is matrix A, right? And then you're also going to need to make matrix B such that it's 2 over, that's not a fraction, 2 over 10. Okay? So then when I rewrite this problem, I can think about it as A times an X matrix, which we're trying to solve for, equals B. So let's grab our calculators and plug in those two matrices. Okay? Where's my calculator? I wish I had my Wabbit back. I miss it so much. All right, so go ahead and go in your matrices and let's plug in these two matrices. Gobble, gobble. So what's it? 2, -4, 3, 1. You don't. We're going to leave that one. Nope, you don't. These are the two matrices you're going to plug in. You are not going to plug in that matrix. I'll show you what happens. I'll show you how to do it. But yeah, just plug in your numeric ones. You don't have a way to do it with the x's. Just plug in your A and your B. Second matrix. So I'm going to go to B. I'm a B. Whoa, 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 whoa. No, no, get out of here, Clune. Get out of here. Oh, no. Easy. Easy. All right, what kind of matrix is this? A 2 by 1? And it's a 2, 10, right? Y'all can't see that on the in the camera. I apologize. All right. All right. Do y'all have, let me know, do you guys have a 2 by 2 and a 2 by 1 matrix, and you have your A and your B? All right. Now, what do we do to both sides to get rid of that A? We times it by A inverse, right? Ooh, let's use a different color. That'd be fun. Why do this when you have fun? This is fun. Now, can I do all that in my calculator without much worry? Yeah. All right. So in our calculator, here's what I'm going to do. Here's what I'm going to do. This is the big step. This is the big step. This is the whole thing that we've been trying to learn. Can I just plug that in my calculator like that, and it'll give me the answer? Yeah. So I'm going to hit matrix A, inverse. I'm going to times it by matrix B. Can I multiply matrices in my calculator? Yeah, you can now. The answer is 3 and 1. That's our X matrix. So that means X1 is 3 and X1 is 3 and X2 is 1. So all I did is I plugged in my matrices, A inverse times B. And that's the answer. Now, hold on, if you ever want to move up in math. So let's do one more. Can I rewrite this as 3 matrices like they did before? Yeah. 5, 10, 7, 6. No, 7, 6. X, Y. 25 over 3. Oh, stop it. Easy. All right. So I can rewrite that matrix. You can multiply to prove it. Now, I just said that. All right. Could you look at that problem and solve it using RREF like we did yesterday? Yeah, make one big matrix. I'm just showing you how inverses work for it. Because you will see problems like this, and they'll ask you to find the matrix to solve it. All right. So let's do it. So what are my 2 matrices I'm going to plug in? A is going to be this, right? And B is going to be this. And then what, if you want me to read I'll rewrite. So I'm going to inverse the one side and inverse the other side, right? So let's plug in those matrices and let's find it. Let's solve this beast. Hey, Mr. Calculator, be my best friend. We were friends. You should have said you're thankful for calculators.
I am not.
Because before calculators, like in my day, we had to do this all longhand.
Like Miss Smarts.
Yeah, she was there with the stone tablet.
They were dinosaurs.
She invented dinosaurs. All right. The dinosaurs went extinct because they had to do their 30 math problems every night, and they said, "You know what? I'm not about this life."
I don't want to end my career.
All right. Yep, it's a 2 by 1, 2 by 1. The good news is if you ever plug it in wrong, you can look. It'll show you, like it shows you visible representation. All right, quick reminder, calculator folks. Do you have your A and B in? All right, so you're gonna do your A. What do you do to that A? Inverse it, And then what do you times it by? B. You just put them next to each other. Negative 3 and 4. X is negative 3. Y equals 4. Yes. All right, that's all I got.
So why never
internet folks.